Hi, welcome back to my MBA course, Building Recommendation Systems in Azure. This is now the fourth module being called Content-Based Filtering and Hybrid Matchbox Recommender. So what we are actually going to do in this module is we are tackling the second main approach in recommender engines called content-based filtering, and then applying this in Azure Machine Learning in an experiment. For this, we are using the module called Matchbox Recommender, and then later on we are extending the content-based filtering approach to a hybrid approach, meaning using content-based filtering and collaborative filtering in one experiment. So let's get this started with the content-based filtering. So with content-based filtering, what it means, or what it essentially means, is we are taking metadata into account. So the metadata can be on, well, all sorts of characteristics or properties on the items. So thinking back to the first module when I mentioned Pandora, applying a content-based filtering approach. Pandora has a lot of information about all the songs, artists, genres, and so on and so forth. And this is the information that is being used to generate more recommendations for the users. But metadata can also be on the users themselves. Here in this case, we are just using metadata on the items. So classifying certain fruits into certain categories. So for instance, the second category is something that is green and sweet. So you see there are certain characteristics or attributes being taken into account so that, to have some more metadata to take into account into a recommender engine. But metadata can also be something like the user item rating triple. So we have certain users, they like certain items, but also give ratings. So if you also think back to the first module when I was talking about implicit versus explicit data collection. Explicit data collection would be the user explicitly says, hey, okay, I want to give this series 5 stars out of 5, or I really did not like this, it's just 1 star out of 5. Implicit data collection would be, in this scenario, would be how many episodes of one series you've seen or you've watched within one day or one night. So the typical binge watching, or whether you have actually just skipped it after 1 minute because it was utterly boring. These are implicit, this is implicit data that can be collected as well. But let's get back to our fruit and kids example here. So here we have our kids again with their preferences, what fruits they like. And then again, the preferences along a matrix form. So here again using the association rules. So this is again a basis for the content-based filtering here as well. And now we have the last kid liking grapes. So we could essentially do a collaborative filtering, which here in this case would be the same as the last girl liking grapes and pears. But it turns out that this is also the same category as mentioned beforehand, 2 slides beforehand, with the green and sweet, or green and berries, and so on and so forth. So this is just very basic, but I think more interesting would be the demo itself. So let's get into Azure Machine Learning Studio then. So now we can actually start off with our demo, which will be using the module called Matchbox Recommender provided in the Azure Machine Learning Studio. Before we go into Azure Machine Learning Studio, obviously we need to worry about what data to get. So going back to the AdventureWorks database that is already provided to us, and we have already imported this into an Azure SQL database, the 2 data sets that are of interest to us, or to the 2 views actually, are these 2 actually. These 2 are then going to be, or these 2 will be joined together because, well, on the one hand, it actually gives us information about the customer, And then, well, more information about the user themselves. So here in this case, the income group, which region the customer is actually coming from. On the other hand, it's also interesting to see what the customer actually bought in our bike shop. So here in this case, we see what model the customer has actually bought. And most importantly is the frequency at which a customer has actually bought a certain model. So here in this case, the whole point with implicit versus explicit data collection, obviously we don't have any ratings given by a customer. So in this case, we just somewhat infer the rating. We infer the rating for a certain model by seeing or just by counting how often a customer has actually bought a model. So this is based on the assumption that the more you buy one model, the more satisfied you are with a model. Obviously, this assumption is somewhat flawed as well, because it might be possible that that you need to buy a model more often because it's failing more often, maybe. But we just want to keep it as simple as possible and just assume that this assumption is actually working. So we see that these two have been joined together, and we can then just take this script to read in the data into the Machine Learning Studio. So I'm going to copy paste this one, go into the Azure Machine Learning Studio and create a new experiment. I will call this content-based filtering, and here we see the reader module. So the same thing here, same thing as in the second module with targeted marketing. We have to specify which database we want to take, which Azure SQL database we want to take. AdventureWorks Data Warehouse 2014. And then paste in the database query from beforehand. So let's just run this for now so that we have read in all the data. We now have read in the data and we can start actually cleaning the data. Obviously, same case as in the second module. In this case, we don't really have to do a lot of cleaning up. This is just for demo purposes. In reality, this would take up about 80% of your time. So for cleaning up, we want to take the metadata editor. The reason is we have a column which is called frequency at some or freq by, or the frequency at which a customer has bought a certain model. And yeah, it is numeric, but we want to make sure or enforce it that it's actually an integer. So here on the right-hand side, we go to the launch column selector and select the frequency buying. Okay, so that's fine. And here, important data type, we don't leave it unchanged. We want it to become an integer. And we might as well rename the column as well. We rename it to rating. The whole point of it is when we use the Matchbox recommender, the data set that the Matchbox recommender requires is something like a triple data set. It consists of 3 columns: user, item, and rating. Here in this case, it's customer, model, and rating. So yeah, which leads us to the next point. We just need those 3 columns for the Matchbox recommender. So then in this case, we just project the 3 columns and drag it in here. Same thing, launch the column selector, and we just specify customer key, model, and then rating. Then we can actually split the data now. So we've done all the cleaning. Now we split the data to actually start building the model or training the model. So same case as in the binary classification beforehand. We split the data. Here the difference is we take a recommender split and leave it as it is. Next step would then actually be training the model. So this is the only difference to the binary classification from the second module. In the binary classification, we first chose an untrained model and then used it to train that certain model on given data. Here, it is already a given untrained algorithm called Matchbox Recommender. So I search for Matchbox Recommender and see that it requires 3 inputs. Training dataset of user item rating triples, so which is here in this case. The second one, training dataset of user features, and the last one, item features. So you see that you can easily extend this content-based filtering approach to a hybrid approach by having some more user features in there too. So we will extend it later on, since we already have some user features. Just as a reminder, we have customer key as well as income group and the region where this customer is coming from. But for now, this should suffice. This is then followed by a score Matchbox Recommender. This time it has 4 inputs. First one, a trained Matchbox Recommender. So this is in this case here. The next one is dataset to score. So this would be the testing dataset that we have put aside beforehand. Then the third one, user features. So this would be the one that we have set aside right at the beginning when projecting the columns. And the last one, item features. So this could be interesting to see, okay, which items are frequently bought together as well. And that's it. So now we can actually just run it now. It has finished running now. We can have a look at the score model as well. Visualizing it, and let's see. Okay, so for each user, it actually compiled a list of items to recommend. And we said beforehand that we want to have up to 5 recommended items as well. So that's all good. We can now save it as well, save as trained model. We save it as content-based filtering and put MVA just beforehand. And then we save it as, save this experiment as a web service. So this would be the next step, taking it to the next level, as in publishing this as a web service. Since we have since we have already saved the trained model, we can just ditch the training process and look at the trained model here. In this case, we see MVA content-based filtering. Put it in here. We are dealing here with a web service, so no need for splitting anymore. Then the next one is, well, we need to think one step ahead. So input and output. Output is probably the easiest. We just want to get the whole matrix as an output. So putting it down here. Input, however, would be then right the second one. The second one, the data set to score. So this is the input that we want. Okay, but here we don't want a triple data set here in this case. Here, as a web service, what I want is to give the customer key and automatically get a list of items that I can recommend to certain customer. And where should this model have all the data from? Well, it's all based on the trained model called MVA content-based filtering. So this should be fine. Okay, I just do it this way. And I just plug it in here. As I said before, I want as an input only the customer key. So I'll just ditch these two, model and rating. But one very important thing to note as well is when you click here on Score Matchbox Recommender, on the right-hand side, recommended item selection. Here, very important, not from rated items, from all items. And then you are set to go for running this experiment. After it's finished running, we then can deploy this as a web service. And yeah, the following steps will be pretty much the same as towards the end of Module 2 with the binary classification / targeted marketing. There you can test it out first, you can download it as an Excel workbook, and here you can have a look at the RP help pages. Here with the customer key, we can try one out actually. Let's try out the very first one. So after it has deployed as a web service, you can go through the same steps as towards the end of module 2 with targeted marketing / binary classification. You can test it, you can have a look at the RP help page so that you can actually integrate it in productive code, or you can download it as an Excel workbook. Let's just test it using one of those customer keys. And here you can actually see what has been recommended to a certain customer. To the customer key 11262 with recommendations of road tire tube, Turing 2000, and so on and so forth. And yeah, you can have a look as well in the AdventureWorks database beforehand what that customer has actually bought beforehand. Going back to our original experiment with the content-based filtering, we now want to extend it to a hybrid recommender, as in actually integrate the collaborative filtering approach inside that experiment as well. Before we actually head off to doing that, let us save this experiment as under a different name. I'll call it hybrid recommender. Okay, so we have, as a recap, with project columns, we've actually extracted only 3 columns. The customer item, as in here in this case, the model that the customer has bought, and some rating as well. Let me just put these ones more towards the right. Then let's have a look at the train matchbox recommender as well. It takes 3 arguments. The first one, obviously, this user item rating triple data set. The second one, some user features, and the third one, some item features. With the user features, we have those user features as well. We have information about the customer as well, in terms of which region the customer is from, as well as which income group this customer would belong to. First of all, I'll just move these ones further down, and then just like on the left-hand side, I'll use a project columns module as well. Drag it in here. I explicitly say which columns I want to keep. So customer key of obviously the income group and the region. Since I'm only taking the first 3 columns, it might very well be the case that there are a lot of duplicates because one customer buys a lot of different models. So to work around this, there's a module called remove duplicate rows. Here, obviously, I have to specify what rows would qualify as duplicates. So here in this case, it would be customer key. We don't need to have 3 rows about the same customer because let's assume that these things, as in the income group as well as the region, do not change. So then in that case, we can drag it in here for the user features, and the third argument with the scoring one is also the user features. So dragging them in here. What to do with the last input, actually, with the item features? So with the item features, let us see what, so with the user features or with the item features, we have only information about which model have been bought. We could extend it with some more information, but let's just attach, or let's just create an item feature set where the first column would be the item itself, as in the model here in this case, and the second column something that doesn't actually give more information to us. So it could be a column full of ones or full of zeros. To have a column full of zeros, we can first use a module called apply math operations. So we use this one, and we use this one to do a Boolean operation. We compare this, or we want to see whether the last
column called ratings is bigger than 0 or not. So greater than, and it's a constant which we are checking against. And the column type would be a certain column name. Here in this case it would be rating. Here in this case, we know that the rating column is always greater than 0 because a customer, or we do not take into account whether a customer has not bought a model. It only takes into account what model a customer has bought and how often the customer has bought any sort of model. So we know that this column will be full of trues, as in either it's true or false, but here in this case, all fields will be filled with true. As the next step, we'll take the metadata editor for two reasons, actually. One reason, we want to rename this column. Okay, let's choose that column again, which in this case is rating. Let's go back to apply math operations, actually, because here, as the last input parameter, we can specify how to output this. If we keep it at result only, the result here would be only one column. But we want to essentially have a data set with two columns. The first column would be the item or the model name, and the second column would be only ones or zeros or whatever. So we take as an output mode in place, as in it will just replace the original column called rating with the new values. Here in this case it would be true. Metadata editor, we specify we want to rename the column called rating to something, let's say properties. Properties meaning these are more information about the models themselves. And then we want to make this column a categorical column as well. Either it's true or false, and we explicitly make them categorical. By making this categorical, we can use a module called indicator value. So this module makes a column which is either true or false into binary numbers, either it's 0 or 1. So we call this again properties and specify this as indicator values. We could either overwrite the categorical column, or we just append it or append another column to said data set. The next one would be then essentially the project columns. Because we don't want all those 6 columns in that data set, we only want 2 columns. So let's delete these ones and say models, and the last one is called properties -1, and that's it. Let me check again. Okay. In this case, let me take these ones out first and run this experiment initially so that it knows which column actually to take. Let's have a look at what the indicator values module has actually given out. Going on visualize, we can see, okay, it now actually contains 6 columns. As I mentioned beforehand, it attaches another column called properties -1, and then as opposed to true, it only gives out an indicator value, either 1 or 0. Here in this case, it only has one unique value, as in only a value called 1, because obviously that's what we expected as well. Here, as the item feature set, we only want to have a data set of 2 columns. First one being the model, second one the properties -1. So let's take the project columns as well and specify which columns we want to keep. here in this case, model and then properties -1. And then we still need to remove some duplicate rows because otherwise our matchbox recommender gets confused which of the rows it's supposed to take. And we know that there are multiple customers buying the same model as well. Here we just specify what would qualify a duplicate row. And then now we can actually head off to train our matchbox recommender. So I'll just type in match and see train matchbox recommender. The first input, as beforehand, it takes in a dataset of a triple dataset as in user, item, and rating. Here, this is the case. The second input is the user feature dataset, which is here. Here in this case, it was the user as well as income group and the region where the customer is from. And then the last one, the item feature set, meaning the item as well as some more information about the item itself, or here in this case, the model. Following the training of the recommender is then the scoring. Scoring model, again, a short recap. Scoring model means applying a trained model on a new dataset. Here in this case, the new dataset would be the testing dataset that we have set aside over here. First input argument is a trained matchbox recommender, which we have just above here. The next one is the dataset to score, so this is that one. The third one is user features, so I'll drag in this one, and the final one, as expected, the item features, dragging it in here. And we can go off and run the experiment. Now that we have finished training the recommender, we can have a look at what it actually has recommended. So we see per user, we have a matrix of 5 more columns. What other items one can actually recommend to a set or to a given customer. The next step would be actually to deploy this as a web service. So in this case, let's save the trained model first. Again, clicking on the button, save as trained model, and then we can save it as a hybrid recommender. Let's then save this experiment as a separate experiment, as a hybrid recommender web service, and then head off. So we don't need this trained matchbox recommender anymore. We have already trained it. So in this case, we look at trained models and find it right here, hybrid recommender. Then we can already specify, since it's a web service, which would be the input and output arguments. Input, we want a web service where I only say I have this customer with me right now. What should I recommend this person? Therefore, only something to the something here to the data set to score. Then the other one would be in this case, so we only want to have all the recommendations as well for a customer. As I said before, and with the input, we only want to give the customer key. So what customer do I have here at the moment? The project columns that we have used in the previous example or previous experiment, we projected, or we've only extracted the columns customer key, model, and rating, as you can see over here. In this case, we don't want to give more information about the customer anymore. We only want to give the customer ID, or here in this case, the customer key. Model and rating, we don't want to give it as an input to the web service, which should be fine. we just drag it in here. The one thing to note though is this scoring model expects an input of 3 attributes: user, item, rating, or here in this case customer key, model, and then rating. So we have to change it to from all items, and that's it. In this case, we are done with creating our web service. We can now run it. We have finished running our web service experiment and now can just publish it straight away. We click here on Deploy Web Service, and within a few seconds we are then forwarded to another site with more information. As we've seen in the second module as well with the binary classification in the scenario targeted marketing, here we can also see the API help page, then the testing button, and we can download this as an Excel workbook as well. For instance, if we take the customer key, some random customer key of 5 digits, after a while we get, or the web service is being called, and we will get a response with in JSON format with some recommended models. And here we get some response as well. For a customer key of 11121, we have the following recommended items to buy: Sport 100, Patch Kit, LL Road Tire, and so on and so forth.
To wrap up this module, what we've actually covered here was first, the second main approach in terms of recommender engines, which is content-based filtering. Showing this as an example using the Matchbox Recommender in Azure Machine Learning. The nice thing about Matchbox Recommender is it can easily be extended towards a hybrid approach. So not only having a user item rating data set, but also extending it with user features as well as the item features. Here, the user features that we've used was the customer key, where the customer is from as a region, and his or her income group. The triple data set that we've used was the customer, or what model this customer likes, and the associated rating with that one. In the last one, we will deal with the recommendation API provided in the Azure ML Marketplace. So this is especially for those people of interest who want to use recommendations in their website and their app and so on and so forth, but just can't be bothered to actually write or do their own experiment. So just tune in the fifth and last module of this MVA course.